All right, so we are just about at the last portion of this investigation called phase change. So the week is going to look like this. We're going to go through the last part of this. By Wednesday, we're going to have our test, our eye check. Thursday we should have Spanish, and then Friday we'll go through that test as well as kind of a review. Okay, so think about reviewing phase change. We've talked about melting and freezing, right? We've done a couple different experiments with that. What does kinetic energy have to do with melting and freezing? What does kinetic energy have to do with melting or freezing? Or maybe I should say, what does energy transfer have to do with melting or freezing? Boy, everybody's so excited to answer this all at once. Guys, calm down. My goodness. Woo. Tori, what does energy transfer have to do with melting or freezing? It will the ice will.
Particles from the water will transfer to ice.
Okay, so if you got two different phases next to each other, the colder one, in this case ice, I think did you say it right, or you might have said it backwards? The warmer one transfers its energy to the colder one, right? Yeah, okay. So depending on which way that's going, if you're transferring energy away from you, that might cause something to freeze. Or if you're gaining a whole bunch of energy, that might cause a substance to melt. Yeah.
I'm gonna talk about a specific thing when it comes to melting, heat fusion.
Okay. What's heat fusion? We just read about that.
So that's the type of energy that is used to break the solid bonds between the energy particles.
Good.
So that the energy can be taken away from this.
And then after those bonds are broken, then is when we would see that temperature change, right?
Mm-hmm.
So if you had 0 degree water and 0 degree ice that's in equilibrium, it's going to take more energy to transfer than normal just to break those bonds, and then we'll start seeing that temperature change. Good. What other kind of phase changes can you think of? Anything else? That's really what our focusing question for this part is. What are all the ways that a substance can change phase? Go ahead and write that down in your book while you think about that. How else might you see a phase change? You got one, Tyler?
Evaporation.
Evaporation. What does that change from what phase to what?
Liquid to a gas.
Liquid to a gas. Okay, that's not freezing or melting, is it? Anything else? What other phase change? We've talked about solid to liquid or liquid to solid. Now you're saying liquid to gas. Yeah.
Condensing,
What is that?
gas to liquid.
Gas turning to a liquid, and we're going to talk about that a little bit today. Okay, so let's talk about gas as a phase, because we really talked mainly about liquids and solids up to this point. I'm going to get some hot water. I might have to refresh it, because I don't know if it's quite hot enough yet. It's going to be close. I think we probably would like it to be a little bit warmer for the sake of our experiment here in just a second. Yeah. We'll talk about it first, and I'll probably fill it up, and hopefully by then it'll be a little bit warmer. Okay, so this hot water in here, this water has been heated, not a ton, but it's getting there. The particles have enough kinetic energy that the water is in the liquid phase. What might happen if I continue to transfer energy to this water? What's going to happen if I put more energy in this water? Well, the first thing, when something gains energy, it's going to get hotter, right? And that's what I'm hoping to do by heating it up in that thing right now. What else might happen if we get it hot enough I'll give you a hint, like 212 degrees Fahrenheit or 100 degrees Celsius. What might happen to this water? Yeah,
It'll start boiling.
correct. Okay, if we put enough energy in this water, it's going to heat up to the point where it's going to start boiling. What happens with something when it boils? In terms of phase change. Amaya?
And it's starting to turn into a gas.
Correct. So we're going to see something that goes from a liquid to a gas. Now you mentioned evaporation before. Evaporation also goes from a liquid to a gas as well, except for it takes time. Right? Boiling is basically speeding up that evaporation process. It's that same phase change from liquid to gas, but it goes very quickly. Yeah.
Is there such thing as, no, like, a gas turning into a solid?
Yes. We'll take if we have time, I'm going to show you a video of how that could happen. Okay, it doesn't happen very often, but yes. So let's talk about this at the particle level. When you think about this getting hot enough to the point where it boils, and you're saying, hey, when it boils, it's going to change into gas. What happens to the particles when the water boils? Because they have been liquid particles, now they're just getting really hot. What's happening inside there? Enya, you got an idea what's going on with all the particles? Getting hotter and hotter and hotter, now it's getting to the point where it's boiling. Steve, I'm gonna take over.
Well, what I'm thinking here is that if you take like a pot of water and it's boiling, it's the bottom of it is where the water's instantly evaporating.
What's happened to the particles though? We talked about this before. When particles get more energy,
They move faster.
they're moving a whole lot faster, yeah. And then they get enough energy where they're breaking those bonds, and pretty soon they're flying off into space. Now they travel in straight lines, but now they're flying off into space disconnected, right? We said that before, that the particles kind of move and roll around each other when they're liquid, but now they've broken those bonds because there's been enough energy, and now they're flying off into space, and that's what makes it a gas. So let's talk about that. We call that water vapor. Okay? If water boils and turns into a gas, where does it go? Well, here in the air, right? Okay? So what does water vapor look like? Trick question. Trevor,
You can't see it
why not?
because it's John. Never mind. Because it's a gas.
Okay, it's a gas, it's invisible. So you do have these little H2O particles that are water vapor, but they're mixed in with the rest of the air as well. When water turns into water vapor, it's a gas, it's still water. Is it still water or is it something else? Would we say that it's still water? Is ice still water? Ice is still water in the solid phase. So water vapor is still water, just in the gas phase. Okay, so how can you tell if water vapor is present? Is there water vapor in the air today?
Yes.
You're saying yes, there is, or yes, you can just tell?
No, yes, there is.
Why? How do you know?
I'm just guessing because that's making it hotter.
Okay.
So it's turning into a gas.
You ever been to the sauna?
Yeah, I like saunas.
Where you just sit there and like, it's really hot? Is that sauna filled with water vapor?
Yeah.
How can you tell? No.
It's kind of hard to see.
Yeah, there's actually so much water vapor, there's stuff, it's probably a little foggy in there, yeah. So some of that water vapor is like clinging to little dust particles. What else?
The condensation on nearby mirrors.
Yeah, you guys are making this trickier than it needs to be. How can you just tell immediately? You walk into a room and like that and you're like, there's water in the air here. It's the same thing that what happens in the summer. You go outside in the backyard and go, boy, today it's really humid, right? That's what humidity is. How much water vapor is in the air. It feels kind of sticky, and if it gets too humid, you don't really like that feeling, right? Okay, but that's water vapor. That's little particles of water in the air. All right, so now I'm still going to get this a little bit warmer, I think. But I've got, I would say roughly 500 milliliters of hot water in this cup. We're gonna observe this. If water in its gas phase is invisible, what can we do to find out if water vapor is present in the air? What do you think?
Making the room colder,
How would that help?
cause if that's still going and it's hot, then if we had a mirror in here or something, there would be water on the mirror.
Okay, another thought? If there's gas air, if there's water vapor in this air right now, how could we tell? For sure. Yeah,
You can look at the cup and see the fog.
okay, so there's some fog right in here. That's gonna help. Really, what we wanna do is go backwards, right? If we could cool down the water in the air, right, cause it was heated up to the point where it broke bonds and it's flying off into space, and now there's all these little particles, because they got so hot, couldn't we cool the air down? Which is kinda what you said. And if we cool that air down, then what's gonna happen? We're taking that water vapor and turning it back into liquid, right? We're changing the phase back to its original, I don't know if you call it the original state of liquid. So, here you go, this stuff is real hot now. Uh-oh, maybe too much.
Wait, is that, what kind of ice is that?
Alright, so as I come around, hot water in there, you see it? You see it? No, Trevor, say what you said again.
Oh, the fog on the cup?
Yeah, what do you think is happening? Why is there like fog on the cup?
Because there's fog in the room.
No.
Because the water vapor is touching a cold surface.
Okay, the water vapor is touching, is it, well, this is a cold surface?
No.
Yeah, I suppose, it's colder, well, not really. Yeah,
Cause the air around is colder than it is in that cup.
could be,
You need to show it to the camera.
okay. I'm gonna add something, we got hot water there, we said we wanted to cool down the air. I'm gonna take, I've got some crushed ice here, whoops. We're gonna go about halfway filled up, and I'm gonna put this inside. Why do you think, or what do you think is gonna change if we take this cup of ice and put it in here? What's that gonna do? Talk about it with the person next to you. You got 1 minute. What do you think is gonna happen? What will we see differently?
Mr. Gum,
Okay, what'd you say? Yeah,
the camera can't see,
you can't see what?
camera can't see.
Not yet.
Um,
Now the camera can
Whoa,
see.
that's crazy, man.
What'd you say? What do you think will happen when we take this and put it in here? Which I think I should check before, yeah.
the ice is gonna melt like the chocolate.
Okay, so some of this in solid state could have enough energy transfer to it where this starts melting. But we're really concerned about the gas, right, the water vapor. What might we see with some of the water vapor? Yeah. Use the word condensation. I think you use that word too. What does condensation mean? That's a good word to use. Matthew.
The phase change in which gas turns into a liquid.
Yeah, so if we can take some of that water vapor and change it back to a liquid, that's condensation. Anything else that we think we might, where do you think we'll see it? Outside of this cup, so out here we're gonna see drips of water. Okay, let me put that in there. Alright, so it's gonna let me take that, we're gonna leave this here, I'll just kinda hold on to it for a couple minutes. I'm not sure if I'm supposed to have this dipped into the water, that probably wasn't good, I probably have a little too much hot water in here. But we'll see what happens in a little bit. Anything else that you think might come of this? Yeah,
Energy transfer
from where to where?
from the water to the ice.
From
Right.
hot water to the ice? Okay, so, and that's what you said, that that would melt this? That's a possibility.
Crushed ice.
Okay, and I don't know how well we can see it in here. Maybe not real well. I'm gonna leave it in here yet a little bit more, but I can see, it looks kind of foggy almost all the way around. I'll come around so you guys can see this as well. Can't see inside there.
Wasn't there already foam?
No, that was on the larger cup.
Oh, yeah, that's a lot of fog.
What is the fog exactly?
I think it's.
When you think of fog, by the way, when they say, oh, tomorrow's gonna be sunny most of the day, but morning we're gonna have a tough commute, it's gonna be hard to see because there's gonna be a lot of fog. Fog really is water vapor, and fog is clouds, right? They're just low clouds. The clouds are really water vapor that are stuck to little dust particles in the air. So when you see fog, fog is water vapor. Okay. Now, I'll do the same thing and pull them apart and walk around with them so you can kind of see. What else do we have? What do you see there? I'm looking at specifically on the outside of the smaller cup that has the ice in it. Where'd those guys come from? All of a sudden we have water droplets, condensation on the outside of the ice cup.
That's crazy, man.
I
That's
know.
crazy.
Why? Where'd it come from?
I don't know.
Okay, here's what I'd like you to do for about 3 minutes or so. Hopefully that's a good enough amount of time. I would like you to draw this experiment on your piece of paper in your notebook. Okay, so draw the larger cup, about a third of the way filled up with hot water. You can label it. Show the ice cup that we placed inside and label it. But now all of a sudden, we have, oh, and did I say the outside? Is that the outside? No. I'm sorry, this is really the inside of this cup. The inside of the smaller cup here has water droplets on it. I didn't pour any water in there. So what you can do is draw that and then explain why we saw a change there. Where did those particular water droplets come from? As you're drawing, we can discuss a little bit. Where'd the water droplets come from that were on the inside of this ice cup? You said condensation, that's right. Water vapor from where became liquid? Amaya? I don't think so. Because the liquid drops were on the inside of this smaller cup. So it wasn't from the air that was already inside here. Which water vapor, which air do you think is now condensed there? Isn't it this stuff? Isn't it our classroom air that's like flowing right up above our the ice cup? So there must be some moisture here in the air. There's typically, unless it's really, really, really dry, there's always going to be some moisture in the air. And so this cool air cooled it down. We also see the phase change that, yeah, some of this ice is now melted. It's water in there. Okay, in your notebook, as you're drawing this and labeling your diagram, please use the word condensation, and you might even want to write down a definition for that. The process of changing phase from gas to liquid is called condensation. Gas to liquid. We didn't really talk about it so much, but we did see evaporation here, which is changing from liquid to gas. Where in our experiment, and where should you point this out? Where did we see evaporation? where we went from a liquid to a gas.
The hot water would fall out the cup.
Yeah, so then all of a sudden this, the air that was, or the liquid that was in here was obviously becoming gas, was becoming water vapor, because then we would see it sticking to the side. Side of the gas was all, or side of the cup was all foggy. Okay, so we saw both condensation and evaporation happening there. Make sense? Okay, that's as far as we're gonna go today. We'll finish this up tomorrow, but go ahead and take the last 2 minutes to get as detailed with that diagram in your scientific notebook as you can, and then I'll clean up while you're doing that.